Next term is instantaneous acceleration. Instantaneous acceleration is the limiting value with delta t tends to 0, delta v by delta t. So we can write in differential form dv by dt. It is equal to d vx by dt I, because vector v can be written as vxi plus v delta v. That means this v can be written as vxi plus vyj. So we replace this x with vxi plus vyj. We can write it as dvx by dti plus dvy by dtj. And it can also be written as, because vx is the x component of the velocity, it can be written as dx by dt. And vy can be written as dy by dt, which we have already written. Hence, it is d by dt of dx by dt I plus d by dt of dy by dt j. And combined form we can write it as d2x by dt2. It is a double differential of x along x-axis plus d2y by dt2j. And hence we can write it as axi plus ayj. With this, we start our projectile motion. Projectile motion is the motion in which an object is projected at an angle theta with the horizontal. An object itself is called the projectile. Suppose this is the horizontal surface, and from this point A, an object is thrown with initial velocity u at an angle theta. So object path is like this. It is due to the acceleration due to gravity, which is acting in downward direction. In this motion, only acceleration is g, which is acting downward direction. There is no horizontal acceleration. Here one point is, or one approximation is, that this g is constant during this motion. That means this motion is very near to Earth's surface and g is constant. We can resolve this velocity in two mutually perpendicular direction. One is horizontal and another is vertical component. The component which is along the theta is actually cos component. This is u cos theta, and another component is u sin theta. And acceleration, there is no acceleration along the horizontal direction. So we can write some initial values, that is ux, initial velocity along x-axis, it is u cos theta, and ax along the x-axis is 0. Similarly, uy along the y direction is, that is the initial velocity along the y direction, is u sin theta, and acceleration along the y direction is minus g, because our conventional direction is positive in vertical direction, positive direction is upward direction. Because g is in downward direction, so we use negative sign. So these are our basic initial velocities along x-axis and y-axis, and the acceleration along the x and y directions. With these values, we have to find some values, some definitions and values, that is time of flight. Number one, time of flight. Time of flight is the time taken by the projectile to reach from point A to point B. That is, it is a time for which the projectile remains in air. Second term which we will find, that is the horizontal range. Horizontal range is the distance covered by the projectile during its flight time. That is, object reach horizontally from A to B. So this distance is range or horizontal range of the projectile. This horizontal range is generally referred by R, capital R. Another term which we will find is the height of the projectile. Height of the projectile is capital H, and it is the maximum height attained by the projectile. So there in between some point at which it will attain maximum height. That means it is the height attained at the time midway of AB, that means half of the flight time. And fourth, which we have to drive, that is the trajectory or the path of projectile. So using this graph, this figure, we have written that ux equal to u cos theta and ax equal to 0. Similarly, y equal to u sin theta and ay equal to 0. Ay equal to minus g. So first we have to find time of flight. That means how much time the projectile remains in air. This was the projectile motion thrown at with u at an angle theta. It reached here at this point. Here initial velocity is u cos theta. So we have to find the velocity, and this is u sin theta. We see at highest point it has only the horizontal component. Vertical velocity component will be 0. That is the maximum height. Because if it has the vertical velocity component, that it will move further higher. So at highest point, vertical velocity will be 0. That means if I say this is A, this is B, this is C, this is D. At D, that is the highest point, I can write Vy equal to 0. Uy I know, Ay we know, and Vy also know. We have to find the time taken by the projectile from A to D, that is to reach vertically when its velocity becomes 0. So we use equation of motion because motion is under gravity. In vertical direction, g is acting downward. Ay is minus g. So using the equation of motion, first equation of motion, that is v equal to u plus at, we put the values in this equation. Vy, our equation is Vy equal to uy plus acceleration is minus g into t. Put the value of Vy, that is 0. Put the value of uy, that is u sin theta minus gt. This implies that t equal to u sin theta by g. This is the time taken by the projectile from ground to reach at the highest point. And because acceleration is same time will be taken by the projectile to reach at the ground by covering the same vertical distance, that is the h. Hence, time of flight will be twice of this small t time. Time of flight will be capital T, and it will be 2t, that is the 2u sine theta by g. So this is the formula for time of flight. This formula we have to remember. This is very important and it has to remember. And derivation we should know because it helps to understand and gives more clarity. Next, we take the horizontal range.